Good morning, ladies and gentlemen of Algebra 2 Honors. Good to see everybody here today. We have some people out helping with elementary school today. Is that it? But that's good. We're normally in this exercise set we'd spend a couple days at it, but we've run out of days, haven't we?
Yes.
Essentially. So we're going to go over just a few of these problems today, and probably 1 and 2, and then 7 through 10 maybe. So the first set here has to do with solving these equations graphically, and what we're going to do is, what we've done in the past is set up an equation here where we essentially have both sides of the equal sign become a separate equation. So I'm going to put y1 equals 8 plus log x, and then y2 equals 2 log x minus 12. So go to the calculator, 8 plus log x so 8 plus log x, and then we have down here 2 log x plus 12. Is it minus 12?
Yeah, it's minus 12.
Okay, thanks for catching that. So, anyway, when we graph these things, does everybody have this in their calculator now? When we go this in a standard window, we go to Zoom 6 to standard window, we see this up here, but we don't see the red one, do we? We see the blue one, but not the red one. And so we have to, if we have this right here, it looks like we might have a y-intercept of negative 12 maybe. So if we go to window here, we go down to like negative 13, maybe we'll pick up that red one, I don't know. Yeah, we do, right? And so what we're looking, our function is undefined at x equals 0, and so if we go look at x equals 0, we see undefined. And then we could go ahead and we could scroll up here and see. Now I hope you notice that these things are moving closer together, but very slowly, right? And so then we can play around with the window. We can try to go to x max being 1,000 and see what that looks like. Okay, and graph it. Well, I'm going to even increase the x window, the y window up here, y max. I'll increase that to positive 13. Okay. But see, does it look like we're any closer together here than we were at the beginning? No, it really doesn't. So we can try greater windows. We can try 1,000,000.
Million?
Or 1,000,000,000.
Oh, Lord.
Okay, we can go by x scale of 1,000,000 of 100 million. Okay, we go at x scale like this. So that's the red one. Where's the blue one?
Oh, gone. I think you put too many
Let's go
zeros.
up here.
Put too many zeros at the Y.
Let's
the
go.
Y scale.
Oh, at the y scale? Well, the y scale, that's probably okay.
I mean the X scale. I don't know.
I'm going to try this here. I'm going to try to go to 20, see if I see anything. Okay, does it seem like they're getting closer here?
Yo.
Yeah, okay, let me show you what you have to do for this. 1 times 10 to the power of 20. Okay. So now we graph.
Dang.
Not even seeing anything. X max.
I think it's too big in case.
Can you send Lexi to the library with her Chromebook and charger?
Okay, I'll try to send her. Okay, now do we see something here? Finally, we see something. Looks, so let's try to find intersection point. Second trace 5. Enter, enter, enter. So intersection, 1 times, this is 1 times 10 to the 20th, and we can go to window. I can go here and make this 2 times 10 to the power of 20. Okay. Now, so how long do you think it would have taken you to figure this out if I hadn't been up here trying to figure things out for you?
About the same time as that right now.
Yeah, it would have taken a long time. And here's the thing about it is one thing I'm trying to bring out in this is that when it comes to logarithmic functions, they are like that. That they can go out. The domain can be forever, seemingly. Now this is obviously not forever, but it's umpteen trillion. I don't know. A trillion is 10 to the 12th power, and so this is quadrillion. I think is 10 to the 15th power, or something like this. So this is like I don't know the number, how you say the number, what this is, 10 to the 20th power, but that's a huge number. But that's one thing you have to watch out for when you solve these equations by graphing, is that the solution can appear because of the nature of logarithmic functions, the solution can appear way out there. And if you can imagine yourself scrolling through here to get to an answer, how long would it take us to get to that power?
Oh, it took forever. You can press table.
It wouldn't take, we wouldn't have enough lifetimes to do it between us, right? we couldn't live long enough to get to scroll that far. So that's what that is.
You can press the plus sign and then get there.
But when it comes to logarithms, we have really large numbers. So we say so x is equal to 1 times 10 to the 20th power. That's what that is. And this also is an example of a lot of times solving logarithmic equations is a lot more efficient to do algebraically. Okay, so we'll do that. What I want you to do is go to problem 2. Can you do that? Go to problem 2 and try to solve it. I don't think it's as much of a, I don't think problem. Now with log base 6, the thing you have to worry about is this. It's going to be y1 equals log of 2x over log of 6. That's how you use the change of base formula. And y2 is going to be equal to 2 log x over log 6 plus 1. So that's how you'd enter those. So go ahead and try to find those. Then after this, I want to go straight to problem 7.
There. I don't even know. What's the window?
You had to figure it out, Mark.
Yeah, Mark. Okay. Oh, I know what I did wrong. Choke. Choke. Mom. Dude, at least mom.
Whoa.
Call me. Huh? What to say? Ellie.
Mr. G, it says there's a here. Oh,
Does it?
hold on, I have to find out what this is here. There we go.
Log 2x over log base 6. So log 2x.
Log 6.
So there we have that one, and then we have this other one is 2 log x over log 6 plus 1.
I don't know.
I already know.
I don't know about that.
Plus 1. So now, so what I'm going to do is, we already have the window all messed up, so I'm going to go to zoom 6 to kind of to get to a standard window again.
Zoom 6.
And so now, so that's going to work, right? I mean, it's not a real tight view, but we can go take a tighter view. We can go to 0 to 2, and like -2 to 2.
Mine's different, Mr. G.
You got zoom 6.
No. Wait, go back. Go back to the equations. What you read for?
Oh,
Wait. Log 2x.
Y'all didn't get this?
That's what happened.
Then it's gonna be like a negative something. The intersection.
I got the marker, got it.
Okay.
Second trace 5 and
Yeah, then you go to second. So on the other one, we were at 1 times 10 to the 20th power. Here, we're to a real small number, right?
yeah, negative.
So what is our answer?
Negative 0.3 repeat.
No, that's
Oh,
not the answer.
it's,
What's our answer?
X equals
Not the answer, Mark.
X equals 1 to the
X equals 1/3 is our answer, okay?
okay, it's 0.3.
oh, we want it in decimal form, Mark.
But I was right.
You weren't.
Okay.
Why did it-
So anyway, that's just a brief thing about graphing. And now I want to go to just skip ahead to number 7.
Number 7?
And so we'll spend the rest of the time just kind of solving algebraically what these things are. So probably, we'll try to do 7 through 10 today. So, and also we bring into something that we've talked about in the past called extraneous solutions.
Yo,
Yeah.
So if we look at problems, let's look at problem 7 first. So you have log base 9 of 4x plus 5 equals 2. What are you going to do to solve this?
you put
Multiply.
log 4x.
And log 5.
Oh, hold
No.
on. No.
No.
You put that
And
4x
five.
plus 5 in the front, and then divide by log whatever, log 9.
No.
Okay, well, you do have some choices here. Okay, I'll show you. Oh.
What does it look like you're drinking?
What can you do to cancel out log base 9?
Sewer water.
What is it?
That's good one.
What cancels out log base 9?
Log base 9.
No.
Oh, 1.
What do we do to cancel out log base 9?
Look on the other.
10. Put a 10 underneath it.
Okay, what we do is we have, if we put 9 to the power of log base 9, is going to equal 9 to the power of 2. Okay? So what's 9 to the power of log base 9?
1.
1.
It's 1, right? So we have left is we have 4x plus 5 is equal to 9 squared, which is
81.
81.
81. Let go.
And then
Then you subtract 5.
Subtract 5.
What's that one? What is it? 70.
So we get 4x equals 76.
Divide by 4.
Yeah, we divide by 4.
What's that?
19.
So x equals 19, yeah.
Pretty.
X equals 19. Now, one thing you try to do, the last thing it says, check for extraneous solutions. How do you check for extraneous solutions?
Well, they're in the calculator.
What we do is we plug this back into the original equation.
Oh, okay.
So we have this log base 9. What's 4 times 19? 76, right? What's 76 plus 5?
81.
81. So 9 to what power equals 81? 2, check. So this is called a real solution,
Yep.
not extraneous. So we check you check, and basically if the function is defined when you plug it back in there, that's a real solution right off the bat, pretty much. Okay, what I want you to do is look at number 8.
Oh my.
It's all eligible.
Are you over here blaming Atlee
Yes.
for stuff she didn't do?
Yeah.
dropped by half. She dropped by half.
She not.
Are you supposed to have a hat on
Huh?
in class?
Oh!
She put it on his head.
She threw it at my head.
Mr. G, this is what it's been.
So you're saying that you're blaming her for you disobeying school rules and wearing a hat?
Yes. That's exactly what happened.
She's forcing me to.
She told me.
So Atlee forced the disobedience going on in this classroom.
Definitely not. Mr.
She
G.
She
spanks
said
him.
either you do that or I'll hurt you.
She
You can
spanks
ask-
him, Mr. G.
You can ask who? Me?
You can ask everyone but them too.
No.
That's Jose. He knows.
Yeah, he knows.
Jose said, I don't need to be dragged into this.
He really doesn't.
At least that's drama. That's what.
Okay, very good. All right, you're doing number 8. You're doing number 8, right?
Yeah.
Right.
Mr. G, can we take it and put it in the front of the LN?
What I would do is I'd subtract ln2 from both sides, and I'd solve it that way. That's what I'd do. Now, what happened is, I actually worked this out algebraically before class, and did it even another way than that. So solving algebraically, there are different ways you can do that and get to the same path. But to me, the easiest path is going to be subtract ln2 and work from there.
Then it would be 6x or no?
I'll be honest.
Oh, yeah, okay, you need to be re-instructed
Yeah.
in the rules of
Combine them.
logarithms. So so let's go ahead and look at this. We subtract ln2, right?
Yeah.
So that goes away. So now we have on the left side, we have ln 8x minus ln2 are equal to 5, right? So what are you going to do next?
Divide by ln.
Okay, we look at the quotient property of logarithms.
Yeah, just look.
What's the quotient property of logarithms? How can we combine these into a single logarithm?
Oh. Over ln.
Okay, let me show you
LN.
what it is. We have ln 8x over 2.
Oh.
That's the quotient property of logarithms. You can look it up. Okay, what do we have left here?
You can
Multiply by ln. Or divide by ln.
No.
Oh, come on, let somebody tell me, what's 8 divided by 2?
4.
ln
Okay.
4 is.
Someone's dummy.
Then you do that property.
So now you do that.
So now what?
Now you divide by ln.
Divide by Ellen. Yeah, divide by Ellen.
No.
No.
You
What do we do to get rid of
It's
Ellen?
not 4x of.
What do we do to get rid of
Ellen?
ln?
Yes.
Put it to the fourth power.
What are they
Or 4
Do you add
ln
ln
4x.
to other side?
Put it in front.
ln is ln is log base what?
Yeah.
It's log base what?
So times 10?
ln is log base what?
1.
That was log base 10.
Oh,
No,
5.
no, you don't
One.
remember anything.
Log base 1.
I don't
You
know.
don't remember anything.
Log base 3.
That's why we have code here. Amen. Yeah.
Okay,
And break.
So it's just.
And Bryce.
Okay, let me do it. ln equals. It's 0. Oh my.
Oh yeah, it's 0.
so ln of e, oops, wrong one. What did I do here? ln
1.
of e, I don't know what happened, equals 1, right? So what do you have to do here?
So what's the?
Oh, that's 1. That's x, isn't it?
Oh, you can do
Put it to the power, yeah.
Okay, here, somehow forgotten, ln equals log base e.
Oh.
So what happens to e to the power of ln 4x?
Cancel
1.
This is 4x.
This is
So we have 4x is equal to e to the 5th power. And so then,
Then you divide by 4.
so x equals e to the 5th divided by 4.
And that's extraneous.
I don't know. E to the 5th,
It's what you got up there, should be. It's 37.1.
divided by 4. Yeah, so 37.103 about.
Wait, why do you have that up there, Mr. G?
Yeah, I have the same answer right there.
It's
Well-
different equation. Is it 0.25?
So about that, and what you can do is if you plug back into the original, you can check that out. ln 8,
ln 8, 3.7.
so ln 8 times, and we go to ans, we should get that, which is the same as ln 2 plus 5, I hope. ln 2 plus 5 should get the same thing, right? Yeah, equals.
What's that?
Real solution.
Real solution.
This whole year I've been trying to.
Okay, what I want you to do is go to problem 9. Here we go, problem 9.
You combine those. Oh, you can combine them. Log.
Log 4.
Log 2x over 2. That's 1.
This is going to involve another property of logarithms, which is called which property?
That 1 property.
Okay, this is called the product property of logarithms. Let me show you. Okay, so we have is ln is log 2 of x times x minus 4 equals 5. Okay? What are you going to do next on this one?
Doing,
Oh my gosh. I just got a really big number, Mr. G.
Yeah. Don't.
Wait,
I didn't do that.
wait.
What can you do to cancel out log base 2?
Put it over,
You
put
put
it to
two.
the power 2, and then you put the 5 to the power 2, but I messed up, so,
Well, 2 to the power 5, you mean.
yeah. that's
Gee,
what I-
Daddy.
So we have this, what we have here is we have x squared minus 4x equals, and what is 2 to the power 5? 32?
Yeah,
32.
So if we subtract, we get x squared minus 4x minus 32 is equal to 0. And then what do we do with that?
Come on. X equals
Actually,
X. What is it gonna be?
it's gonna be 4, it's gonna be,
X.
it's gonna be 8 and negative 8 and 4.
Mm-hmm.
So negative 8 and 4,
Yeah.
does that look right?
Seems all right.
Okay, let's go ahead and solve this. So x is equal to what?
Negative,
8.
negative 12,
No.
no, negative 6.
Gee.
Hold on, y'all.
Okay, you guys need to be, I don't know what you guys were doing. You guys were asleep in class or something.
Mr. G, wouldn't you just, okay.
So zero factor property. So x minus 8 is equal to 0. X plus 4 is equal to 0.
0.
So X equals 8, X equals negative
X equals 8. X equals negative 4.
Extreme.
Now, you should be able to look at that and figure out that these are the solutions, right?
Yeah.
Okay, let's go back here and plug these in. Now, what happens if we plug in negative 4 here?
It cancels. Or
What's
you
negative
can't do
4
that.
minus 4?
0.
It's
Negative 4
Negative 8.
minus 4 is not 0, it's
Negative
negative 8, right? Can you have log base 2 of negative 8? No, you can't, okay?
Uh-oh.
So this one right here,
no.
this is called an extraneous solution.
Watch that. Bueno.
Extraneous solution. If you plug in 8, will that work?
Yes.
Yeah, you can plug in 8, you can have log base 2 of 8, that's 3, and log base 2 of 8 minus 4, log base 2 of 2, that's
Gonna be fine.
2, 3 plus 2 equals 5. So this one right here is called a real solution.
Not big.
Not fake, real. And extreme, real extremes.
You know what's big?
So last one I want you to work on is number 10. We'll just kind of leave it there for class today.
Literally.
What I would do here on this one is I would go ahead and separate out this negative 2. So you'd have log base 6 of x equals negative log base 6 of x minus 1/4. And then you'll have minus 2. Then you could add this and combine and simplify.
Oh, this is a lot.
So what you'll have is you have log base 6 of x plus log base 6 of x minus 1/4. And that's going to be equal to negative 2. What will you do next on this?
Combine the log x, 6x. and
How do you
log-
combine these here together?
So it can go log,
Log base 6
Oh, no, I meant.
of x times x minus 1/4
Yeah.
equals -2. Then what?
Yeah.
Yeah.
Then what?
uh,
Okay, 6, right?
Power 6.
So that cancels, so we have x squared minus 1/4 x. And what is going to be 6 to the -2 power?
1027.
0.0, yeah.
What's going to be, it's going to be 1 over 36.
Yep.
Okay, that'd be 1 over 6 squared. So what can you do to solve this? Multiply by
4.
36, right? Cancel that out. So you get 36 x squared. And what's 1/4 of 36? No, what's 36 times 1/4?
9.
9. So you get minus 9x. And then you have equals 1. And so you have 36 x squared minus 9x minus 1 is equal to 0. And then what's going to be our factoring of this guy right here? Well, you'd have plus or minus 1, right? You know that, if it's factorable. So what are you going to have for the rest of this? 36, 12. 12 and 3, right?
Yes.
So let's see, is that going to be, which one's going to be what, 12x? Is that going to be 12x here and 3x?
It's gonna be,
No.
gonna be backwards?
Yeah, it was 3 right there. And then,
I think this is 12x like this.
Oh, yeah.
Because then you have negative 12x
oh, yeah.
plus 3x. So you have 12x plus 1 is equal to 0. 3x minus 1 is equal to 0. So in this case you have x is equal to negative 1/12. And then you have x is equal to 1/3. And so I'm not sure about extraneousness. I think this one right here, this -1 will be extraneous, because then you'd have the log of a negative number. So this will be extraneous. This one's going to be real. I hope it's real anyway. Yeah, I think that would be real. So anyway, that's as far as I want to go today.
You wanna pick them up, Mr. G?
Yeah, I want you guys, especially Jose and Marcus, I want you to hold on to your paper for your test tomorrow. I want you to do that.
Oh no, test over this.
Well, it possibly could be. There could be 8, 10 problems on it. Possibly could be.
Okay, so the rest,
Yeah, pick up the rest.
Gee, we literally did 4, 6.
Can you make the test over like what we were doing yesterday?
Most of it will be. Most of it will be.
It was easy.
But the thing about it is, you're going to be able to have your calculator with you also, so it's not going to be so bad.